Not only that, the typical battery experiments have shown that the battery fluctuation for these type of application isn't that severe, and it probably results in almost zero wear or consequence of the battery anyway.
Much better than totally charging and discharging. Yeah, actually, that's absolutely true. Is there a question in the back, or did we get it? No.
Thank you. So in light of that statement, why would FERC not treat energy storage as a generation?
They do, also.
Okay.
I mean, that's what they're dealing with. So if it depends, and it's almost like it depends. So if you have a business model and you want to put it in on the transmission grid, and you want basically a guaranteed rate of return, so you're making a 15% rate of return and you're happy with that because you make it over 20 years, then that's your business model. If you want to put it behind the meter and you're putting it at a customer resource and you want to dispatch it like generation, you may make a 40% return some years, you may make 5% the other years. It really depends on how you want to use your asset. What FERC is recognizing is that you can't put batteries on the transmission system and say, oh, today I'm a generator, oh, today I'm a transmission, because you're cross-subsidizing. Because one is you're basically baked into rate base, and the other is you're saying, I'll take the risk of the market, but then I get the high side and the low side. It's the difference between using cost of service regulation and basically market-based regulation.
If a megawatt is a megawatt, how do you push toward a low carbon system? You mentioned earlier you didn't want to have a cap and trade system, which is basically for the purposes of
I don't want. I'm saying that it'll take a while, so let's get Binghamton's bill passed, and then we can move to a cap and trade.
I understand. Well, you said we don't need one, but the point of cap and trade, at least theoretically, and I'm no advocate for it, but is to reduce the amount of carbon that's being put into the system. So if you have every megawatt being treated equally, doesn't that tend to sort of sustain the status quo to some extent? How do you push people toward what you ultimately want to achieve, which is a very low carbon system?
No. It's just not the way the markets work. So the way the wholesale markets work, which will then become if we go through a real-time pricing, will be the prices of the retail markets. The wholesale markets take the way the Cal ISO does, all the ISOs do it, is people on a daily and a real-time basis will bid in what the load is, and then folks bid in generation, and there's a single clearing price. So consequently, the studies have shown by having a single clearing price, everyone will bid in as close possible to their marginal cost because they want to get taken. And the last unit that is on to serve the last kilowatt of demand sets the clearing price. So if in fact you have a cap and trade system where in fact there are costs associated with running high carbon units, you're going to have to bid in at a higher price in order to be able to clear the market, and it'll basically, it's an external cost, but it'll increase your internal price, marginal cost, and therefore coal or carbon-based resources will naturally go up in price relative to non-carbon resources. So the market clearing price would be reflective of that. And then the other piece is that if you add in requirements for increased scrubbers and things like that, of course, those are investments that also have to be recovered in the price. So having fully transparent prices and then integrating the externalities, which is the carbon effect of running fossil fuels, will drive up the relative cost of coal and oil-based resources as compared to non-carbon resources, which won't have to pay those taxes or emissions.
If you have more slides, because we do need to
sure.
move on here and wrap up within the next few minutes if we can.
Okay. Well, the point here is that FERC is saying we should move towards having distributed. So if I could then talk about then how storage then works in this environment. So this is a picture, a typical picture of a smart grid, where we're talking about having these effectively microgrids or systems within systems where you have storage that could be used so that when load appears on the grid, it appears as virtual power, that you're reducing power. And This is actually the business I'm in, where we take those resources and we optimize them. So now suddenly what we are looking at is how you use storage behind the meter to combine with distributed renewable resources as well as load, firm it up, and then bid it into the grid as virtual generation. And an example, if we use this, actually this is a Philadelphia campus. We actually also have, working with University San Diego, UC San Diego, to develop a microgrid on their campus. But the point is, and this gets back to the economics, so we did a typical 10 megawatt customer. So if you were to look at this customer, this blue line here is the wholesale LMP. This is the wholesale prices. So this is a typical day where at night the prices dip down and they peak during the afternoon. What we're showing here is this is what the customer would have consumed if they simply kept their thermostats at 72 degrees during the day and 80 degrees at night. Again, I know it's hard for folks in San Diego, but in other areas of the country, temperature does fluctuate. And then this is what the building as optimized would use. So this is what happens when you start using storage. You basically consume more at night when the prices are lower, and then you drop during the day. And in this example where we have solar and battery and a little bit of distributed generation, we're showing that when the prices are highest, the customer is essentially selling all their ability to control load back on the grid as virtual generation and essentially are becoming independent of the grid during those hours. The net effect is that this is the benefit, and I could do the math quickly, but basically this is what they would pay for all the load they consumed during the time that, or the energy they consumed off the grid. It's $6,000. They have incurred a fuel cost of $13,000 because they have some generation they're running. But as a result, the difference is that they also, during these same hours where they're not buying, they save themselves $6,000 by just not buying during certain hours. And the other piece that the missing money is that the RTO paid them $17,000 by their willingness to shift load and move to grid-based or their own generation and sell back what they were not using to the grid, so that their total benefit is $11,000. So that's how they pay for the resources. So rather than just looking at my ability to use storage on an internal resource to save money, what the markets allow them to do is monetize that resource, that capability on the market, so suddenly they become a revenue source. And that, under our model, and I'm sure Terry would say the same thing, is this is how you turn moving these distributed resources to an asset for the customer as opposed to just an expense. And that's the end.
So, but if you were somebody that wanted to build something to take advantage of this in California today,
It's okay.
I was saying if you wanted to take advantage of this and build something, a system that would do this in California today or specifically in San Diego today, you couldn't really buy and sell on the market like that because of regulations. Is that correct?
In California, yes, once you re-regulated, there are some entities that are grandfathered in, but the utilities run programs like this that you could sell into the utility, and the utility would then resell it.
But you have to be big
market.
to do that, right? You can't be a homeowner or something.
You would have to work with an aggregator,
Okay.
which, there are plenty of companies like ours who would aggregate various homeowners and be your representative into the market.
So I guess my main question is the conference organizers have mooted that they will communicate with Schwarzenegger and Sanders about these things. And what in your
this
opinion
model,
should we communicate?
In this model, what should be communicated is that not providing end-use customers direct access to the market is slowing down progress, not advancing it, is my mind. Is that there's no reason, this is just a resource on the grid, and there's no reason to go through a utility because the utilities will dictate the pace of change. And so long as utilities are economically neutral, they shouldn't care. I mean, that people are moving into the market. It's only when you have an integrated utility that's actually trying to sell you supply and provide you distribution service that they should care about the outcome. Yes?
Thank you. I was wondering if you could touch on another actionable item, as was suggested here, you mentioned the cap and trade bill versus the Storage Act, and I believe what the message was, it sounds like the cap and trade bill is an example of the road to hell is paved with good intentions, so it's probably not going to get us to where we need, but the Storage Act, which is much cleaner and transparent solution, might. So how would the local community, the local business community support that legislation? What would you suggest?
I wouldn't, I don't want to be quoted in saying the cap and trade is, because I'm not an expert on that. What I'm suggesting is that the cap and trade bill is ripe with controversy. It is unlikely to get passed in any time soon or soon enough. But we have a need right now that goes beyond monetizing emissions to really recognizing the value of storage on the grid, that the Bingaman bill already embraces that. Let's just move on these, continue to debate cap and trade, and the only thing that does is that then it sets us up with an industry structure that we can deal with cap and trade where there are true alternatives. I know this is a sore point in California. It's almost like giving people real-time pricing, but they can't control usage. So, okay, now I know how much I'm paying, but I still can't do anything about it. Let's give people a chance to do something about it, then give them the prices, so now they can then have a real way of modulating their behavior in light of having real prices. Once you have if you have cap and trade and you have storage, then in fact people have alternatives that you can switch to that are rational and reliable alternatives rather than just paying for the cap and trade. So it's not an either or, it's a question of what step do you want to take first. If we gave everyone in California ability to manage their load and then did real-time pricing, wouldn't the result have been a little different than just saying, well, here's the prices, now we'll teach you how to manage it. It's sort of chicken and egg problem.
Audrey, we'll have to wrap it
Yes.
up. Thank you very much.
Thank you.
Thank you very much.